Hello. I'm going to try to automate my own job. Right now I work on an assembly line. Assembly lines were invented by a man named Ransom Olds. So if you want to thank anyone for affordable goods, he probably deserves the most credit. I like the job, don't get me wrong, but doing the same thing over and over and over again is really repetitive. If you are going to do something tens of thousands of times, it might be worth the effort to build a robot to do it for you. This right here is the LED I built. It's a pretty simple light fixture. It's basically an aluminum frame with two steel side frames, some electronics inside. We sell them to a lot of people. We sell them to a lot to Amazon. I even sell like an order to Tesla, so it's probably to the Gigafactory. Right. This right here is Thomas Edison. He's the man who productized the light bulb. He figured out how to really make it affordable and usable for the average American. Brighten up the world a little bit. And right now, I work at his company still, the Edison Electric Company, which is now known as General Electric Lighting, building light fixtures. I think that's pretty cool. This is just the aluminum sheet that gets stamped out, and this is what houses all the stuff inside the light. It's very lightweight, easy to work with. It's got some screw holes right there, and those are important because that's where you attach the walls. This is the wall. It's got two slots right there, and that's where the screw holes overlap. And then it's got a tab that folds up here, and then the tab slides into the bottom of the plate, or of the base. So all we need to do is we need to figure out how to attach two walls to one base, and then put screws in, and then move it along. I'm no stranger to building robots. I've built many robots in the past. This is probably the most complicated and difficult robot ever built. And I still think it's going to be like maybe 10 times easier to build than this one. I built this robot when I had access to a team of people who could help me, and a laser cutter, and everything was bought for me. And it only uses like 4 motors, compared to like the 10 or 12 we're going to use to build this one. So let's go over some of the technology we're going to need to use to build this robot. This is what's called a screw presenter. It's actually something I've always dreamed of building, and then I found out they exist a couple weeks ago. What it does is you pour in screws to the top, and then it sorts them into a presentable manner, so the screws always come out facing the same way. And you can put your drill down and pick up the screw with a magnetic bit, pull it up, and use it. Very useful. This is a pneumatic impact screwdriver. This one has interchangeable bits on it. So the way this one works is you put the bit over the screw, and then you put the screw over the place in the location you want to drill into. We have a predetermined hole for us. You could use this with like a drill bit though. And then what you do is you press the screwdriver down, and it automatically starts screwing in. This one again's pneumatic, so it should be hopefully a lot cheaper than the electric ones. I saw like a lot of them, like the industrial level ones, are kind of going for like $1,000, like the ones that we use on the factory line. This is a linear gear. I'm pretty big fans of linear gears for linear motion because they're very robust and dependable. Basically, what you do is you hook up a motor to this gear right here, and it turns, and then that pushes the rack along. and that's very important for good linear motion. We're going to use a lot of linear motion. That's going to be very consistent. The nice thing about this is that you can kind of like line up the rack in a slot or location so it doesn't deviate too much and always stays in the same spot. We're going to be pretty consistent for what we're doing. This right here is a Vex motor. It costs $45. I know how to use this one. It's a very good motor. I'd recommend it if you really need a good motor. It's not too big, you know, but still decent size. Still, though, I do think it's a little bit pricey for the project because, I mean, we're going to need like 10 to 15, maybe 16 of these. So, what I'll probably do is I'll reserve these ones that will be made by 4 or 5 of these for like moving big things or important things. And I can always torque them, you know, in case if I need to do like a cheaper option. And then what I'll do is I'll go to the hobby store where they have a whole bunch of RC parts, and I'll buy some of the cheaper motors for maybe some of the things that require less demanding motors. Or if I could just find a better deal there, that'd be nice. This is called a Cortex. It's a computer. Well, you plug your computer into it, and then you upload the project, and then what this does is it has like timers and inputs and outputs, and so it sends electricity to the slots. What you do is you plug in the wiring from one of your motors into like one of the slots, and then what it does is it sends electricity to the slots, powers the motors. You can also hook it up with a sensor, so electricity goes from the sensor into this thing, and then it goes to the computer inside, and then you get an output, comes out into motor action. So right here is kind of what I'm looking for the automatic filter for the base frames. The base frames, they stack very easily. They come pre-stacked actually, which is really convenient. And they're very lightweight, so you can stack them pretty high. And also, importantly, they have a small gap in between them when you stack them. So because of like their geometry, there's a small gap that you can fit a dowel in, like a metal rod, in between the gap, and then you can hold the frame there. So what we're probably going to have to do is we're going to have linear gears here, and they're going to pull out the dowels, and then what we'll have is we'll have like a stack right here, right? And so if we pull out the dowels, the entire stack falls, and then we put these dowels back in, and those dowels will go into the gap, and they'll be between one plate and another plate. And then these dowels will come and it'll drop like a couple centimeters onto the steel walls. These dowels go back, these ones open up, drop it in. It's just a simple feeder. Right here we're looking at this would be like the base, and these would be the two walls. So we're gonna have the two walls. They're gonna be fed through a kind of similar system along right here, and then those walls are like they have little tabs on them, and so the aluminum base will drop onto the tabs, which has to be about like at 30-degree angles, like the maximum you can go on that. And make sure they fit still, and then that'll hold them in place. Hopefully gravity will be enough to do it. The aluminum frames are pretty light, but I don't want to waste another motor pushing it down, but I think we should be fine with that. Worst case scenario, we can like lower the feeder onto this thing, but like we still have the dowels like holding it up, but it's only holding it up a little bit, and this stuff is still pushing pretty far down. Yeah, we have barely enough room to do that. So worst case scenario, we could potentially do that. And then we just need to make a force to kind of push the walls up, so I have the tabs coming over the frame. I was thinking personally what I was going to do is put a linear gear that runs right here, and it's going to push a spike up, and it pushes that spike up. It also activates a reloading mechanism to put another wall on here. This is where we're going to do the screwing. of the walls and the base. So this will be by far the most complicated thing and be really difficult to build. The way this one will work is we'll have two screwdrivers, or we'll actually have four because there's 4 holes we need to drill in. I'm going to start by building the frame, testing with 1 screwdriver, and then I'll upgrade to 4 if it finds out it's working okay. And then we're also going to have 4 screw presenters, 1 for each drill. And the screw presenters will get us the screws we need. And actually, let me go back a little bit. So when we're looking at this view, there's going to be a linear pusher, like a linear gear, with a plate attached to it that will push this thing forward once the walls are in. And then there will be wood on the sides, big beams, with probably plastic attached to them that will make it like low friction. That will keep the plates attached and stuck onto the frame. And then that will get pushed into this view. You can see the walls here. And so the steel walls will be attached right here. They'll be held up against the aluminum frame. And then the screwdrivers have to come down over the top of it into the holes. So the screwdrivers will come, they'll be pushed this way by probably linear gear in the center, or that will like drive them opposite directions of each other, or maybe even 2 linear gears on each side that will move the entire thing. I mean, these things might end up being pretty heavy because we also have to have a motor that can push them down. That's pretty strong too. And there's going to be 2 of them that we have to push down. So we might need to use quite a bit of motors for this one. Or at least torque them very heavily. But I also want this thing to be fast. So I need a lot of motors and a lot of torque. The screwdrivers will come, they'll come down, screw in the walls, then they'll come back up, move along the side of the beam, and then come down again in pretty much the exact same manner as they did right here onto screw presenters, and then they'll have a magnetic bit and they'll be very slow. The magnetic bit will kind of fall into the drill or the screw will fall into the magnetic bit, and then it'll come up very slowly, come over, down, screw in, and just repeat that. And then this thing will be pushed out of this area by the one that pushed it into this area, but there will be a spacer in between it, which will also be very convenient for reloading it. And the spacer would be another aluminum and 3 steel walls, or 2 steel walls. So I just want to talk about the importance of automation real quick. I think automation is really not valued enough. I think there's a lot of wasted engineering talent. I mean, I see it at my own company, you know, like they're not even trying to automate. And the thing we have is actually pretty difficult to automate, especially with the wiring, but I think they should start on it at least. I think by automating we can really improve the quality of life that we all have. I mean, I think when people do the same thing over and over again, you're really kind of wasting time, because I think life should really kind of be about new experiences. When I was first learning about the world, I was really hopeful that there was a big push for automation, but only real serious technology people kind of embrace it, and a lot of times it's not really technology people running the corporations. Although when they do run, they run it quite successfully. So I personally am going to try to do this. I think this project will cost somewhere between $500 and $1,500, which is about probably like a week or week and a half worth of pay. But I'm completely willing to put down that investment because, you know, I really want to see things move forward in life. You know, I want to move towards tomorrow.